Okay, so hopefully you've already read the step-by-step instructions before this part A. If you haven't, press pause, read all those instructions, and then follow through with this graph. So I'm going to show you how to graph, first of all, y equals cosecant of x. In order to graph y equals cosecant of x, you first of all need to graph its reciprocal. Its reciprocal is y equals sine of x. Notice I wrote it with the same b value and the same a value. So the b value is 1. Therefore, the period is 2 pi divided by b. So 2 pi divided by 1, so it's 2 pi. The distance between critical points is always the period, which is 2 pi, divided by 4. So the distance between critical points is pi over 2. Even though this says at a minimum each graph must have 2 cycles, I actually today want you to make every scale for all your graphs the same. And in each of these graphs, I want you to make every 4 to be pi over 2. So go ahead and label every 4 distance critical points is pi over 2. So we have pi over 2, pi, 3 pi over 2, and then at the end is 2 pi. And then do all the opposites. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then I want you to make sure you leave enough space to graph the reciprocal. So the amplitude of sine is 1, of this graph is 1. So that means the max is 1 and the minimum is negative 1. I'd like you to go up 2 to make 1 and go down 2 to make negative 1. Now because this is sine, I know that it starts at the SA and it's positive sine, so then it will go to the max. I'm just going to go ahead and graph all the critical points for sine. So we have SA, max, SA, minimum, SA. There's the right side of the origin. And then I'm going to graph the left side, so it goes minimum, SA, max, SA. Okay, so that's the sine graph. We use the sine graph to get the graph of cosecant. So there are a few things you need to remember about reciprocals is that the reciprocal of 0 is undefined. So all of the places where the sine graph is equal to 0, that means its reciprocal is undefined. So that's going to be all of these points on the x-axis because that's where it's 0. So I'm going to just go ahead and draw in vertical asymptotes wherever the sine graph is 0. So it's really at all of the SA values. Okay, the other thing you need to remember about reciprocal functions is that the reciprocal of 1 is 1. So wherever sine is 1, this cosecant is also going to be 1. And then the reciprocal of negative 1 is also negative 1. So wherever it's negative 1, its reciprocal is also negative 1. The next thing you need to realize is that the reciprocal of a really small number, like 1/8, for instance, the reciprocal of 8 is, this reciprocal of 1/8 is 8. So as this gets closer and closer to 0, its reciprocal is going to get bigger and bigger. So here's what happens. Each of these go in the opposite direction. So you have these little U's here, and then these ones are going to do the go down. So really the blue that I've just drawn, that is the graph at the cosecant, and the asymptotes, the sine part is just there to help you draw it. If you want to, you could always go back and erase your sine curve. Okay, now we're going to do part B. I've already set up my scale the same as the first one. Make every 4 pi over 2 and go up 2 for 1 and down 2 for negative 1. So the reciprocal of y equals secant of 2x is y equals cosine of 2x. So now the b value is 2. So the period is equal to 2 pi divided by 2. So the period is pi. Therefore, the distance between critical points is pi over 4. Now notice, I still labeled everything, every 4 pi over 2. So those pi over 4s are actually going to be halfway between each of those. You don't have to label all of them, but I'm going to go and put slash marks so every 2 is going to be a critical point on my cosine graph. Okay, so let's go and graph cosine of 2x. Remember that cosine starts at the maximum, so at 0 it's going to be at 1. Since the distance between critical points is pi over 4, at pi over 4 it's now going to be at the SA, and then at pi over 2 it's at the minimum. So these critical values are going to be every 2 spaces. Once you've drawn in your cosine of 2x graph, now we're going to draw in our secant graph. Again, remember, wherever cosine is 0, the secant graph is undefined. So at all these SA values, you're going to draw in your vertical asymptotes. And then wherever cosine is equal to 1 or negative 1, the secant is equal to 1 or negative 1. And so I'm going to go ahead and draw in all those values. So the blue points are my secant graph. And then in the middle right here, I see I have this u going up, and then to the left I have this u going down. It's going to get closer and closer to those asymptotes, but never touch them. Over here, I'm just going to show the right half. So the blue and the red are my actual graph. The pencil line just helps me to draw my graph. Okay, now we have part C, y equals secant of 1/2 x. In order to do this, I'm going to graph y equals cosine of 1/2 x. This time, b is equal to 1/2. So the period, remember, is 2 pi divided by b. So 2 pi divided by 1/2, which is really 2 pi times 2, so the period is 4 pi. Therefore, the distance between critical points is 4 pi divided by 4, so the distance between critical points is pi. I'm still going to label every 4 is pi over 2. And I'm still going to go up 2 for 1 on the y-axis and down 2 for negative 1. Now, cosine starts at the max. So at 0, it has a point at 1. But this time, the distance between critical points is pi. So now at pi, I'm going to do a point at the SA. And then at 2 pi, I'm going to do at the minimum of negative 1. And then going to the left, negative pi is going to be at the SA. And negative 2 pi is at the minimum. So we're not going to show more than one cycle on this one, and that's okay. Now, wherever the cosine graph is 0, the secant graph is undefined, so draw in those asymptotes. Only going to have 2 this time. And then to graph your secant graph, do just like you did before. Wherever it's 1, it's 1. Wherever it's negative 1, it's negative 1, and then draw those u's.